You can write these out or not, however you want to do, but we're going to go through them really quick. So the assignment that I gave you was to do 3 different structures: CH3I, NH3, and H2O. Those are the ones I had you do. Okay, so I'm going to show you the structures of these when you're done. Okay, I'm going to go real quick and just show you the final structure, and then you guys ask questions. What do you think?
Did we have to do the structure on the right though?
I would like you to get used to drawing the structure for me, because this is what you see in biology textbooks, and this is how you get there. So questions on that one?
Does it matter where the eye is located?
Right, the eye could be here.
Okay.
The eye could be anywhere, because you know what you can do, if this was really cool and I could work this, I could go take this and just kind of turn it
Why is that
90 degrees.
one only have one?
Which one?
Hydrogen.
Oh, because it didn't mark it very good.
Okay.
So I could go like this, turn it, I could turn it again, I could turn it again. This is the same structure no matter how way you draw it, because if you take and pull it off, do it 3-dimensionally, that iodine could be anywhere. Okay? Based upon how you're turning it. Alright, so those who were gone yesterday, I'm going through this really quick, but I think it's going to be beneficial when I went through those first 6 steps. And then we're going to build upon that today, and that'll help you out. Okay? The next one, NH3, would look like this. Any questions on that? Any? The reason why we show the pairs on the center, we'll get to on Thursday. You have to wait till Thursday. We'll go, well, why do you have to do that? Why can't you just leave them empty? We could, but it's going to be beneficial for Wednesday when we have to do some things with shapes. Okay? All right. And then the last one, H2O, good old water. You guys have been drinking your H2O today, right?
Mm-hmm.
Drink your H2O. Increases your metabolism. It replenishes what you've lost. This is what you're putting in your bodies. So this is what your structure will look like when you're done. Any questions on that? Make sense? Okay.
Yes.
Time out. Please leave.
What's that?
Time out. Time out. Please leave.
It makes sense 3 times.
I'm good at this.
Structure makes sense.
What does Coach Johnson say? He says the same thing.
Makes sense. Myers like he's like, all right, today we're doing 3 by 10. Makes sense?
Yeah.
Yeah, makes sense.
I think if you listen to Johnson, that's one of the things he'll say like, that makes sense, guys? All right. Now, we're going to have you do one where you're going to go through all the same steps, 1 through 6. Do them step by step. If you've done it, you haven't done any of these, the people that were gone, you haven't done any of them, do them step by step. I'll come around and help you once you get to the point. Then you're going to find out it doesn't work. And so we have to add a step 7. I know, it's the last step you have to do though.
I love steps.
Yeah, steps are good. Especially when you understand them. Right? So this is what I want you to do. We're going to do N, H, and S. We're going to put that structure together, starting with number 1, going through 6. Okay, if you were gone,
There's 3 different.
3 different elements. You'll write out 3 different symbols, notations for them. Then go through the steps, 1 through 6. NHS. So this one, N has 5, H has the 1, and sulfur has 6. So there's 12 electrons. Then we put nitrogen in the middle, surrounded by sulfur and hydrogen. Then we go ahead and do the pair in between. Okay, step 4. Step 5, make sure all the branched atoms get its 8 electrons before the center gets any. Sulfur is the only one you need to do because hydrogen only can have 2. You never put any extra pairs around hydrogen. It has its 2 and that's it. So when we count them, it's 10 electrons. So we take that extra pair, you can't put in, this is what students will like to do. They'll like to add in, don't do this, don't add in two extra electrons. Just because you know nitrogen needs 8, and so hey, I'm going to be free to give. I'm going to give out an extra 2 electrons I don't even have. Okay, it's kind of like buying something you don't have any money in the bank. You're going to get caught. It's not going to work. Okay, so when your final structure should look something similar to this.
Makes sense.
Okay, questions?
Does it matter if we have it on the side or on top?
Nope. As long as it has 6 around it. Now this becomes a problem. This is where we got to add step 7. What we're going to have to do is we're going to have to determine which element is willing to give up an extra pair. There's some elements that once they give up their 2 electron, or their 1 electron to share, they're done sharing. I'm not sharing anymore. They say that's it, no more. I'm not going to give any more. And then there's some elements that say, yep, I'll give you a little bit more, but then this will be the most I'll give you. And so some of them are more giving than others. All right, some don't give, but just one, and then we need to talk about that and why, so that you can actually figure out where that extra pair is going to come from when we have extra sharing take place. Okay, so that's step 7. So you can add step 7 on, write that down, and then we'll talk about step 7 and some specifics about it. So we reviewed steps 1 through 6. I showed you how to do when they're all single bonds. Now we've got double bonds. Double bonds and triple bonds we're going to have to form. And so I need to show you how that's going to work with these Lewis dot structures. That the center atom doesn't work out. It doesn't have 8. It has 6, or it's going to have 4. It's going to be one of those 2 cases. Then we know we've got a multiple bond, which is either double or triple bond that we're going to have to form. So we're going to have to make a decision of how that's going to look. Now, the definition kind of goes on, so if you want to write the last part of that definition, you can. Just a little bit more detailed at the end. So we're going to have to figure out what elements will want to share extra pair of electrons. Well, how do you determine? How do you know that? How are you going to figure that out? Well, I'm going to give you some options here to show you of how you determine it. And you can just use your periodic table. All families act alike, so they're all going to kind of bond alike when we talk about multiple bonds. The next slide says hydrogen's not going to form multiple bonds. It can't. It can only form single bonds. That's it. Also, group 17 can only form single bonds. There's no multiple bonds that can be shared extra when you got chlorine, bromine, iodine, that whole group. Can't happen. But then as we work to other nonmetals, we can have extra sharing take place. We can share extra. They're willing, they're capable of sharing extra. Okay? You know, this time of year, there are some individuals that can share extra. They've been blessed. They've got plenty, more than probably plenty, and they can share extra. Like the food, they took in more than they've ever taken in this year. It sounded like on the radio that the food pantry, they've had to find space to put the extra food that they got. So there was a lot of people willing to share extra. Some people can't. It's not possible. So these atoms, some of them can share extra, some of them can't, and these are the ones that can share extra. Hydrogen, group 17 elements can only share single bonds. They can only share one time. If we get to group 16, if you look at group 16, it has 2 spots that can be shared. So group 16 can form a double bond. Because when you write out the structure like group 17, it's got one spot it can share. Right here. That's the only place it can share. Where if we look at group 16, it can share in 2 spots, and those 2 spots could be shared between two atoms. So that would be your sharing of your double bond.
What's that picture of? That
What picture?
Under group 17.
It's just an X that represents chlorine, fluorine, bromine, and iodine. It has 7 dots around it. When you do a dot notation, that would be 7 dots. If you do group 16, it'd be 6 dots for oxygen, selenium, and sulfur. So group 16 can form a double bond. Group 15 can form a double and a triple. Double and a triple. So it can share in 3 spots. So if I would show a symbol that would be like phosphorus and nitrogen, it has 3 places that it can share extra. Maybe I'm giving you too much information here, but there's 3 spots it can share. There. Okay? You don't have to draw those out. Those just show you that you can have 3 places that can be shared. Okay, and then group 14 can do all of them too. They can do singles, doubles, and triples just like 15. So I probably should say group 14 and 15, but I kept them separate. Okay, so we're going to go back to our structure and kind of see where we can share extra and how that's going to look when we're done. I will go back to that slide. But for those who are a little ahead, group 14, you can write that down, and I'll go back to that slide. So as we work from right to left, they can acquire more multiple bonds. And if you look, group 14's got carbon in it, and carbon is basically the element of life. When you look at anything that's living and look at what the base element is, it's carbon. Okay? Carbon is the element of life. Carbon-based. Proteins, carbohydrates, DNA, RNA, all that kind of stuff. It's all, a lot of it is carbon is the main element that kind of hooks everything
So we're
together.
made of carbon?
Yep, we are made of carbon with hydrogen, mostly carbon, hydrogen, and oxygen. CHO, that's pretty much us. And that information of making proteins and all that kind of stuff is through that process. Alright, so we go back to our original one.
Go back to that other one.
Okay? We go back, well, I'll go back to that here in a second. I'm going to finish up this structure that we have written out. Oh, I didn't write that one out, did I? Did I?
No, you were like right here.
Okay, we're here. So where's the extra pair come from?
S.
S. Now look at group 16. S, can it form a double bond?
16?
Yep.
Yep.
Okay, they can form a double bond. So what we'll do is we will get rid of one of these unshared pairs of electrons outside. And then we're going to share it in between. We've taken one that was unshared and we shared it, and that's our double bond, and then when we draw our structure, it's going to look like this. There's our double bond.
Okay, why don't you take from nitrogen that other one?
Here,
Yeah.
because if I do it and bring it over, nitrogen will still have 6. If I decide to take this and bring it over here, and then keep, sulfur would have 10 and nitrogen would still have 6. So I have to pull from a branched atom. I have to pull from a branch. Because if I did it that way, this is what it would look like. Hydrogen has 6, sulfur has 10. So it has to be pulled from the branched atom. Okay, so this would be not what we want to do. Okay, so I've got four of these for you to do. You go through the same steps. They're all going to be multiple bonds. So please follow your steps. Some of you just don't want to do that, and I get frustrated when I ask you, did you follow the steps? And you say, well, what steps? I don't know what steps you're talking about. Okay? They're written down. I'm going through this. It's all in vain if you don't use them. So I don't know why you would take the notes to do it and then decide you're just going to do it. Just do it. Okay? So 1 through 4. Write those out, and then I'll come around for those who have questions as you go through them.